Alright, I'm going to record for this period.
No.
We're looking at section 2.2.
Can it hear me?
Of course it can hear you.
So I can go home and watch this and hear everyone talking.
Uh-huh.
Wait, you can even hear like if I was wait, what if we like get yelled at? Wait. If I was talking to bears?
Yeah, it's recording right now. Can you hear you? It's not a joke. Maybe not that low, but depends.
Are we on some sort of live TV show?
Yeah, there's a live feed right now. Say hi.
Is someone gonna pop out and yell friends?
Alright, tell me now.
Am I being punked by Justin Bieber? Is he coming out of that closet?
New topic today. This topic we're going to look at is not on your test.
Do you get it, Seth?
This topic today is not on your test tomorrow. Remember that. Now, somebody tell me in their own words what it means to accelerate or what acceleration means in general. Tom.
It's when you're going at like a certain pace and the pace increases.
Good. You're going at a certain pace or rate, or in this case velocity, and that velocity changes. So if you want to put a definition, change in velocity over a time period. Again, acceleration is a change in velocity over a time period. I'll give you a formula, and it's very straightforward. You'll see right away. Acceleration is a change, delta, in velocity over a time period. So in words, what I just said is represented in one simple equation right here. Acceleration is a change in velocity over a given time period. Now, this should look similar and familiar to you. You know what it looks like if you remember? It looks like your other formula from yesterday. Velocity equals delta x over delta t. Take a look. Exact same format, right? But instead of delta x up here, you now have a delta v up here. Instead of a v here, you have an a over here. But it's the exact same idea, okay? So velocity is a rate. This is a rate of a rate. So it's saying, how fast are you picking up velocity? So for example, you're in your car and you hit the accelerator. It's called the accelerator because you gain speed. The brake is really called the, you ready that word? What's the brake called? The decelerator. Close. The decelerator, because you reduce your speed, okay? Now, with this, my units. What are my units of velocity? Generally speaking, velocity, what are the units? What is it? Meters per second. Be careful, not and. Meters per second. What are my units of time? Seconds. Come on, we just said this a minute ago. Now, that means that my units for acceleration are going to be meters per second squared. Again, I've got a second in the denominator here. Mathematically speaking, it's the same thing as if we move that second down below. So now we're left with a meter up top and second times second down below. These will be my dimensions. And whenever you write dimensions, you're going to see brackets around them in physics. When you see brackets, it's indicating the units or the dimensions. Okay, whenever you see brackets. I didn't use it in the first chapter as much.
Wait, but wouldn't, I would just think it would be like meters. Why wouldn't the 2 seconds cancel out?
It's, ready? Meters per second divided by a second. When you divide by a fraction, or when you divide by a number, you have to multiply by the reciprocal.
Yeah.
So it's the same thing as this. Second squared. Alright?
Yeah.
Alright. That's what acceleration is. Let's go right into an example problem. Okay? It'll help us to understand this a little bit. So we've got a bus. So imagine you're in a school bus or a shuttle bus or a city bus, whatever it may be. So a bus slows down at or with an average acceleration. That's one word, average. The smartboard's going to help me there. Acceleration. I should just make a disclaimer. Any misspelling, we'll blame it on the smartboard. You? So much enthusiasm. All right. A bus slows down with an average acceleration of 1.8 meters per second squared. How long will it take to come to rest if it slows down from 9 meters per second. Okay? How long will it take to come to rest if it slows down from 9 meters per second? Question mark. What's going on in this problem? Give me just a visual. Somebody describe the scenario. Seth.
A bus is stopping, and its velocity was 9 meters per second, and now it's at 1.8. So to find the change in that, we would subtract.
Close. You had the right track. Anybody notice a little mistake along the way? Helen? You're good so far at the beginning.
Wait, the bus is stopping, so we are multiplying. We're multiplying by the acceleration.
That wasn't the question, Helen. The question was the little mistake that we had there.
Oh, I thought you were talking about like. Oh, never mind. I don't know then. I don't know.
Tom?
I think her mistake was that she said that we're starting at, I forget.
Starting at 9, that was
Yeah.
correct.
And then, but we're going down by 1.8.
Yeah. This is the acceleration. This is not the final velocity, okay? So it's coming to rest. What does rest mean? Am I moving? So what's my velocity?
Zero.
Good. So for this problem, here's what I want to do to start.
I have no idea.
For this problem, if we listen, it might help. For this problem here, a bus slows down with an average acceleration. So right away, write down your acceleration, your given acceleration. The word is there. Look at the units. Meters per second squared. That's an automatic that it's acceleration. So you start with your formula, or you start with your variable acceleration equals 1.8 meters per second squared. Now, if I'm going in one direction and something is stopping me, what kind of a sign does it really have on it?
Stop sign.
What is it?
Negative.
A stop sign. Negative, yes, negative. So this is going to be a negative here. Again, think about it. If you're slowing down, we said a minute ago, that's why I used the word decelerator. I said the brake is a decelerator. So when you hit the brake, you're slowing down. So your acceleration is in the negative direction. It's telling you, I'm going this way, but I want to stop. I want to stop. I'm decelerating. So that's my first thing. Next, how long will it take to come to rest? If it comes to rest, the final velocity is 0, because it's at rest. That's final. So we know at the end of the problem, it's going to have a final velocity of 0. The question becomes, what is the initial velocity in this problem? What is the initial velocity that it starts at? What is it? Why? You got it right. What's your reasoning? Because it says from 9. Look, I'm not trying to trick you here. It says it slows down from 9 meters per second. So this is like your starting point, and the ending point will be the 0. So VI, the initial velocity, is going to be 9 meters per second. Okay? Now, this is a problem now that's different from yesterday. Yesterday we had a constant velocity the whole time. Now we have a velocity that's changing. But that's not a problem because we have a formula. The formula we know is delta V over delta T. This is what we put up on the board a second ago. What does delta mean? Change. Change. So, Helen, I saw your hand go up. Can you tell me how I would write this?
Well, like it would be 9 minus 0 for the delta of V. Because
Okay.
that's the change in velocity.
Final minus initial always, so go backwards.
Oh, wait, what? So it'd be 0 minus 0 minus n, so negative 9.
Okay, and then the bottom is going to be? Do I know the time period?
No, it's a question. We don't.
So what do I have to do with these two values here, guys? Just flip them. Very good. So just go like this and switch the two of them. Okay, so we know the acceleration. So now we'll put the acceleration in the denominator. So our acceleration is down here now. And instead of acceleration here, our time period is here. Again, just flip them. Notice the acceleration, wasn't it negative? I'm going to have a negative here. I'm going to have a negative there, which becomes, and my time needs to be positive. So if you had put this as 9 and this as 0, you would have had a positive up here, 9. But then you would have a negative down here. So you would get a negative time, which does not, it's not possible. You can't have a negative time.
Wait, is that a negative acceleration?
So all this.
Correct. Negative acceleration. So we're going to have negative 9 over negative 1.8, which turns out to simply be 5. And my units are going to be seconds. My units are going to be seconds there.
Because 2 to the second cancel out, right?
Because the two things cancel out there, yes. 2 to the seconds, the meters. Again, tonight is studying. Over the weekend, or actually, yeah, tomorrow is Thursday. I'll see you on Friday. I'll see you tomorrow, but we'll pick up with this on Friday.
I'm gonna go play that stuff at.
We don't play Friday.
Helen.
You guys don't have Friday? All right, then I'll tell you tomorrow.
Helen. You want me to do that?
Again, get in here quickly tomorrow.